All right, let's see if we can work on this first problem in our assignment where we're adding three forces together with the graphical method. Now I'm going to take a little detour if you don't mind, and I'm going to insert this picture out of our assignment so that we can have it to refer to. So forgive me, I'm going to go to the Insert tab and Attach, and down here I'm going to make sure that I'm looking for image files, not drawing files, and I think this one, yes, there's a picture of this that I happen to have scanned at another time. So I'm going to say OK, and I'm going to, I don't know what size to make it, I'll just put it there. Okay, I'm back. That's just so we can have a picture to refer to easily without having to bounce back and forth. All right, so back to the Home tab. Where were we? Let's draw these three forces. Now, there are angles given here, and I want to show you a couple of ways to draw those. So one, let's look at that 6 kilonewton force. I'm going to get a line, and I have my dynamic cursor on. So I'm going to type a 6 into the distance box, and I don't hit enter. I'm going to hit tab to tab over to the angle box. Then I'll type 10, and now I can enter. So there's that first 6 kilonewton line. And I don't have an arrow on the end. I get freaked out by those arrows, so I kind of wait till the end to put them on. I want to show you this thing called polar tracking. I don't know if you have used it before, but it's kind of handy. I'm going to click on the settings here. And right now, I have my polar tracking set to click in every 15 degrees. Just looking at our problem here, I notice not everything is a multiple of 15 degrees, but they are all multiples of 5, so I'm going to choose, I'm going to choose to click in every 5 degrees. And if I open the settings, you can see here's polar tracking. Here are all the choices that we have, and if I choose every 5 degrees and OK, then what's good about that is when I start a line with polar tracking on, at every 5 degrees, see that green ghost line that appears? This thing clicks in every 5 degrees because I've got my thing set every 5 degrees. So let me try that 3 kilonewton line. I will type a 3 and tab. And now, right now, I'm straight up and down at 90. Let's see, what is 90 minus 35? It's probably 55. I should use a calculator. That was stupid to do it in my head, but I'm being reckless. So 90 minus 35 is 55. And when I get close to 55, it clicks in because I've got that polar tracking turned on, and I can just hit enter. OK. And now let me do the third line. That 5 kilonewton force going down, sort of downish. I will type a 5 and tab, not enter, but tab, so I can get over to my angle box. And what is 90? Here I'm clicking in near 90, or 270. What is 90 minus 30? it should be 60. Click, click, click. There I am clicking into 60, and I will just hit enter. Yay. By the way, how do we get that dynamic tracking thing turned on? If you don't have that showing up on your computer, go over here in the very lower right corner, the hamburger stack, and that stack of hamburgers, that's what they call it, is a list of all the buttons that you might have on your taskbar down here. And I don't have dynamic input on my taskbar. There's no check mark there, but I'm going to click that, and now I can just click out in space and that'll go away. See that thing there? That showed up because I clicked my hamburger stack, I chose dynamic input, and now there's a dynamic input button on my taskbar, and it's on. If I unclick that, and now I try to type a line, I got no dynamic input box thing. But if I come back here and turn it on, now I do have a dynamic input box thing. Okay, anyhow, here are my three forces. And I am going to leave these here so in case I mess up, I don't have to start over. I am going to copy those three. So I will move them over here, move a copy over here. And now I'll leave this thing intact and I'll go over here and mess with these. All right. Well, I should have put arrows on these because it's going to be hard to remember what direction they were pointing. So maybe, you know, a smart person would make this whole line and the arrow all one polyline, but I'm not that bright. So now a thing with these arrows that's irritating is when you try to make arrows, I'm going to get a polyline, PL for polyline. When you try to make arrows and the O snap is turned on, it tends to want to snap to your line. You definitely need the O snap turned on at the start of your arrow thingy, but then you want to turn your O snap off while you make the two parts of your arrow, and then turn your O snap back on so that you snap back at the end of your arrow. Okay, now I'll do another one. And allow me to tell you that the F3 key at the top of your keyboard turns your O snap off and on. So I'm going to do a polyline, enter. There's my first endpoint O snap. I'm going to hit the F3 key on my keyboard. Yay, it turned O snap off. Make another thing. Now I'll hit the F3 key again. Yay, it turned O snap back on. Okay. And one more arrow down here. Polyline thing. Arrow, arrow, arrow. Okay. So there are my three arrows. I made my arrows all different sizes. That's stupid looking, but oh well. And now I need to stick these tip to tail, and right now they're all tail, 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 so that's not going to work. Well, what order should I put them in? Who knows? I will try moving this one. I'll move its tail attached to this one's tip. Okay, and now be careful. You have to go tip to tail, not tip to tip, not tail to tail, but tip to tail. So I'm going to move my third arrow so that its tail hooks up to this one's tip. Well, that's kind of funny looking, but that's okay. I did go tip to tail. Now I'm going to get a different layer. I'll get the resultant layer so that it stands out. And now I will draw a line. I will start at the start point. I will head off to the end point. And looky there, there's my line. And according to our answer key, it says this line should be approximately 10.2 long. Well, if you round it off, it is. And it should be at an angle of 5 degrees below 0. It is! Oh, yay! So there's that. Before I forget, I need to come in and make my arrow. Make sure my arrow is pointing towards the end point. And now I need to put two things on here. I need the magnitude of my arrow and I need the angle of my arrow. For the magnitude, I could use an aligned dimension. I can't use linear, but I could use aligned. Oh, I need to be on the dimension layer or it'll look funny. So I could use an aligned dimension, and I know that many of you are using that command. And so there's my length, and I would come in here and edit this text and add kilonewtons to my text just to be cool. So I could do that, or I could use the distance command. Up here in the top, there are some measure tools. There's distance. I like to type DI for distance. Click one point, click the other point, and now it is giving you a readout. It's telling you your distance is 10.16 something. And here in this, whatever you call these lines down here, it's giving you the X and Y direction, and it's also giving you the distance. So good. I could then just do a text. I have no idea what size my text is going to be. This might be bad looking. I will try 10.16 kilonewtons is what kilonewtons is what I got, and I could move my text up there. Now I need an angle dimension. And for this, I need a straight line to measure off of. So I'm going to turn ortho on. That's this button down here. I'm going to draw a line that's nice and level. See that? Because now I need to make an angle dimension. Now I'll turn ortho off so it doesn't mess me up. Now I'll get an angle dimension. Angle, and it says select line. Okay, there's one line, there's the other line, and there is my angle dimension. According to this, it's actually 4.7 degrees. So if you round that off, it's 5 degrees. But I'm going to leave it at 4.7 because I like to be more precise. So this right here is my answer to the problem. I could label all these arrows that I stuck together. If you want to do that, that's great. You don't have to. They must have their arrows on so we can see where we did the tip to tail. But what we really need is the resultant. Here's the magnitude, here's the sense with the arrow, and here's the angle with the degrees.